example x1, determine the signs of the trig functions of an angle in standard position with a given measure. So I guess it should say of the 6 trig functions, we're going to determine the signs of all 6 of them. We got 87 degrees. And what you want to notice is that 87 degrees is going to be in the first quadrant. That's a big deal, okay? Knowing where we are, which quadrant we're in, is a big deal because that's going to tell me what's positive and what's negative. And so I think maybe the easiest way to do this problem is to remember you're saying all students take calculus. Since we're in the first quadrant, that A reminds me that all 6 of them are positive. And so that's what we'll say. All 6 trig functions are positive. All 6 of them are positive. You could list them out. Sine is positive, cosine is positive, tangent is positive, cosecant is positive, secant is positive, cotangent is positive. I think it's easier to just say all 6 of them are positive. Okay? So then we look at 300 degrees. Part B says 300 degrees, and you have to be able to visualize where that is. To me, it makes sense to know the quadrantal angles, the ones that are multiples of 90. 90 is straight up, here's 180, over here's 270. If you go all the way around, that's 360. If you can visualize that, it's not too hard to pinpoint 300 in the 4th quadrant. Okay, so we're looking at the 4th quadrant. Think about you're saying all students take calculus. That C in the 4th quadrant is supposed to remind you of cosine. Cosine and secant, its reciprocal, are positive. Cosine and secant are positive. And what that means is, what that implies is, the rest of them are negative. So maybe I should have said that. Let's try that. Cosine, secant are positive. That means sine, cosecant, tangent, cotangent. Then the next one, part C, we've got negative 200. Now it's tricky because we have to go around backwards. That's what that negative means. Negative means we go around backwards. So here would be negative 90, here would be negative 180. That means that negative 200 puts us about right there. It looks like we're in the 2nd quadrant. 2nd quadrant. All students take calculus. So it's S for students, S for sine, and its reciprocal cosecant are positive. That means that the other 4, cosine, secant, and tangent, and cotangent, are negative. Example 6 asks you kind of the same question, but backwards almost. All right, identify the quadrant of any angle theta that satisfies the given conditions. So when they say sine theta is greater than 0, that means positive. That means sine theta is positive. Okay? Sine theta is positive. So imagine where that is. We know sine goes with y, and we know where the y numbers are positive is up here in quadrants 1 and 2. Okay? But then when we look at tangents, okay, tangent theta is less than 0. It's another way of saying tangent theta is negative. Tangent theta is negative. Okay? That's a little bit harder to have memorized, but let's think about our saying. All students take calculus. I know tangent would be positive in the 1st and the 3rd, but that's not what they want. They don't want positive. They want where is it negative. Where is tangent negative? Tangent is negative in the 2nd and the 4th. Okay? So put those 2 pieces of information together. We want to know where sine is positive and where tangent is negative. It looks like we're in quadrant 2. Okay, the next one is weird because it says cosine theta is positive. So cosine goes with x. I'm talking about here and here. But then when I've got secant theta is less than 0, that means negative. But secant is the same thing as cosine. It's the reciprocal, right? And so another way of saying secant is negative is saying cosine is negative. And so we're looking at where cosine is negative. And so if you try to put those together, where is cosine positive and secant negative, it's not going to work. This is impossible. You can't do both of those things at the same time. Okay, next, we're talking about the range. And to me, I feel like your range, maybe you were given a bad definition before. Okay, when you did this in Algebra 1, you probably said something about the y values. Range is the y value. So that's a very limited definition. I would rather you think of this as the output. Because when you look at a question like down here, there's no y. There's no y value in the equation. We're talking about output. Okay? And so the range for the trig functions, when you look at set builder notation, okay, I want you to try to make sense of that. I know it's difficult to read, but I want you to try. This says that the value of y is going to have to be less than or equal 1, or the magnitude of y is less than or equal 1. I think it's easier to see over here. Okay? If you look at it in interval notation, it's a little bit easier to see that that output, that range, is going to be between -1 and 1. That's your output. Okay? So on a calculator, if you tested this out, you'd have to do like, okay, cosine 75, sine 54. See how those numbers are in between -1 and 1? That's your output. That's what we're looking for. Okay? Tangent theta and cotangent theta. Y is a real number here. That just means basically it's any real number will work. And then when we look at secant and cosecant, this says the magnitude is going to be bigger than 1, basically, bigger than or equal to 1. What that means is it's not between -1 and 1. Okay, so look at those ranges. Example 7 says, determine if this is possible or impossible. Sine theta equals 2.5. Sine theta equals 2.5. Okay? I'm not talking about y values, I'm talking about that output. Okay? Is it ever going to be possible for my output to be 2.5? No, because the output has to be between -1 and 1. This is impossible. Part B says tangent theta equals 110.47. Is it possible for my output to be 110.47? Yes, that is possible, because tangent theta's range is basically all real numbers. It's anything. How about secant theta equals 0.6? Secant theta equals 0.6 is going to be what, possible or impossible? Impossible. Impossible. Because what this says right here is that output can't be between -1 and 1. It's going to have to be 4, -7, something.